All right, this is going to be a quick demonstration of what to do in your notes for today. So there's a table. It asks for the number of sides, the number of triangles, and you have number of sides, number of triangles. Then you have the sum, and you have one regular angle. Right, so we have triangle, quadrilateral, pentagon, and so on down to an n-gon. And on your note sheet, you'll notice that there are most of these shapes on the bottom of your page. So what you're doing, triangle obviously has 3 sides. It's not a trick question. A triangle is one triangle. We know that the sum of the interior angles of a triangle is 180. And if you have a regular triangle that's equilateral and equiangular, each interior angle is 60 degrees. Now, the quadrilateral, right, if you go from one vertex to another and put in a diagonal and never cross any diagonals, I would just start from the same vertex every time, then you get 2 triangles, right? 1 triangle, 2 triangle. The measure of its interior angles for these 3 angles is 180, and the measure for these 3 are also 180. So we have 4 sides, 2 triangles, 2 times 180 is 360, and if it's regular, it's 90 degrees. Again, when we come to pentagon, we get the same thing with 1, 2, 3 triangles. So 5 sides, 3 triangles, 540 degrees. And each interior angle would be 108 for the pentagon. Now you're going to do the next 2 on your own. You should pause the video, do them on your own. One of them has a diagram for you to do, one does not. And then once you have them finished, unpause, and we'll talk about at least the n-gon. So again, you should have paused your video. We have hexagon and heptagon here. That's 6 and 7. A heptagon should have 4. And a heptagon should have 5 triangles. That is 720 and 900. 120 and 128.6. Now an n-gon is not a nonagon or an anything else like that. It is an n-sided polygon. So it has how many sides? N. This would be like if it had 23 sides, we'd call it a 23-gon because it has 23 sides, right? So it has n sides. How many triangles does it have? Well, judging by the pattern in the table, right, a heptagon had 7 sides, 5 triangles, hexagon 6 and 4. Looks like it's 2 less. How did we get the sum? Well, we took the number of triangles and multiplied by a triangle's sum of its interior angles. And to get the last part, we divide by n. The backside of the table then talks about the exterior angles. So it's the same kind of thing, though I'm going to leave a little bit more for you to do. We'll look at these two. Number of sides. It's sum of exterior angles and one exterior angle. All right, so if we have our triangle, an exterior angle is if we extend one side where it's formed by a side of the triangle and an extended side. So it should be straight off one of each side. If we look at a regular triangle, each of those interior angles is 60. So each exterior angle would be 120. And then the sum of the exterior angles would be that 120 times the number of sides, which is 3. So that would give us 360. Similarly, in a quadrilateral, we know that if it's regular, each of these is 90. Since it's supplementary with the linear pair that's next to it, that is 90 as well. There are 4 sides. 4 sides, one at each angle of 90, gets us 360. So you should pause the video and complete the table. And when you come back, we'll talk about the rest. So again, hopefully you did that. You paused the video. You figured out that for a pentagon, you have 5 sides, 360 degrees, and 108 would be 72. And for 6, you got 360 and 60. And for 7, you got 360 and 50, 51.4. And then an n-gon, you got n, 360, and this last column is 360 divided by n.